Welcome. This is the 8th video in our series of statistics, and in this video we're just going to give a single example about why it's not a good reason to confuse correlation with causation. So, our example is going to follow sunscreen. So, suppose you randomly select a group of 1,000 people from across the United States, track their use of sunscreen, and whether or not they get skin cancer over the course of many years. Then suppose further that you find that more regular use of sunscreen is associated with higher rates of skin cancer. So people who use sunscreen more often are seemingly more likely to get skin cancer. So is our research an observational study or an experiment? It's an observational study because we didn't impose any treatments. We just tracked individuals. We tracked the variables for the 1,000 individuals. Do we suspect the sunscreen is causing cancer? Why or why not? No, we don't have enough information. We only have an observational study, have correlation from an observational study. And then we're asked, what lurking or confounding variables might explain your results? Sun exposure. Those using more sunscreen might just be in the sun more often. And therefore at higher risk. There's also genetics. Some people just might be more predisposed. Have a higher chance. And they might be the ones using sunscreen. So what are these lurking or confounding variables? In general, they're some variable that affects both the variables you're studying. That you're tracking. So you might be trying to draw this picture where A is causing B, but really there's some variable C, a confounding variable, that's affecting both of them, and that your initial causal arrow is actually just observing C but not keeping track of it. So that's just one example where you have to be careful about drawing a causal conclusion from data that really just points to a correlation. Okay, see you in the next video.